Hey everyone, and welcome to Generative Now. I am Michael Mignano. I am a partner at Lightspeed. For years, people have dreamed about making a fully autonomous vehicle a reality, and now AI is making that dream a reality. And so this week on the podcast, I speak with Chris Urmson, the CEO and co-founder of Aurora, a company that makes software for autonomous vehicles and specifically freight trucks. I spoke with Chris about the challenges of designing AI systems that mimic human-style driving and why he believes that AI is the key to safety and the success of self-driving technology. Hey, Chris.
Hey, Michael, how's it going?
Good. How are you?
Doing really well.
Thank you so much for doing this. I know how busy you must be right now. There's a lot going on in your world. So appreciate you taking the time out of your day to speak to me.
Yeah, no, really appreciate it. And of course, Lightspeed has been an investor with us and, appreciate all the support over the years. So thank you.
Yeah, no, our pleasure. So look, there's so much to get to. I think, self-driving, autonomous vehicles, like these are topics that so many people in the world are talking about right now, especially given some of the recent advancements on the consumer side, which, obviously has a lot of exposure to the American people and people throughout the world. But you've been at this for a very, very long time and not just necessarily in the consumer sector. And, I thought it would be great to lay the groundwork to some of the broader topics I hope to get into with you, maybe just to give the audience a sense of your background and your journey, because, for all the people that are just finding out about this technology now, like you've been at it basically since the beginning. And so, yeah, if you wouldn't mind just sharing a little bit about your story.
Yeah, happy to. So I kind of stumbled into this space back in 2003. I think it was. There was this DARPA Grand Challenge, and the idea was we were going to build robots to race across the desert from LA to Las Vegas. And to me at the time as a grad student, that just sounded cool. I'll be honest, I'd been working on robots that moved at 15, 30 centimeters a second, which if you imagine, your grandmother with a walker, like that's how fast they were moving. And the idea we'd have a truck drive across the desert at 30, 50 miles an hour just seemed unfathomable, and like a lot of fun. And so worked on that. The first year we went out to the desert and our vehicle went the furthest, and it went about 7.5 miles, and it got stuck up on a berm and basically burst into flames. And so, it was supposed to go 150 or something like that. And so
150 miles.
It's supposed to go 150 miles, and we went about 7.5. So imagine an Olympic marathon and someone goes 2 miles, and that's the furthest anyone goes in it, right? But we did do it at 40 miles an hour. And so the Defense Department said, that's pretty exciting progress. Let's take another run at it a year later. And we came back 2 trucks the next year, 2 of these big Hummers, and we ended up finishing second and third. And again, exciting. We were disappointed, of course, to lose to some junior university out here on the West Coast at Stanford, but it went okay. And then they said, okay, you've driven across the desert. Let's actually drive on roads. And instead of just being on the road at all, you have to be on your side of the road. There's going to be other traffic. And this was the Urban Challenge in 2007. And that was really the first time we started to think about, or at least I started to really think about the implications for people in, and how we could move people through the world more safely. That competition, the first time they held it, we ended up winning it. It was really exciting. There was lots of, exciting robot moments as we had, MIT and Cornell crash into one another. So I think that was the first ever recorded robot car crash. Vehicles driving around. They had stunt drivers out in the course that created extra traffic for them. So really an exciting day, and one of those moments where we're like, oh, this is going to happen. This is coming. And then I spent a couple of years working with Caterpillar automating these giant haul trucks. So imagine a dump truck the size of your house, driving at 40 miles an hour, moving ore from one part of a mine to another. And so really exciting. And then in 2009, Google reached out and said, hey, we're thinking about doing this secret project in making self-driving cars. And would you like to come out and lead it?
How'd they find you? Were you surprised?
I knew some of the folks. So I knew Sebastian Thrun, who'd been a professor at Stanford and then had gone on to Google to help to build what's now Street View and did a bunch of work in mapping. And so we had been staying in contact through the competition. I'd been the technical director for the team at Carnegie Mellon. And Sebastian and I had been talking about doing something together, maybe starting a company. When he was at Google, he talked to Larry and Sergey about it, and they said, hey, why don't you do that here? And so then the rest has been history. And so I spent about 7 years at Google, helped found what's now Waymo, led that for that 7 years, and ultimately stepped away from that in 2016. Spent a few months trying to figure out what I wanted to go do next, and ultimately settled on founding Aurora. And found two great co-founders in Sterling Anderson and Drew Backnell, who had experience launching Model X in the first version of Autopilot and had been one of the kind of really early and deep researchers in artificial intelligence, machine learning for robotics, and Drew, one of the world's experts in that. So we came together and said, okay, let's go make self-driving vehicles happen for real and use the experience that we'd built from all of these different places and try and build something special.
And my understanding is Aurora is mostly focused on freight. Is that right? But you also do passenger vehicles. Like, I would love to hear a little bit about like the journey through Aurora to settle on a market and maybe focus on one versus another.
Yeah. So when we started Aurora, we were pretty clear we wanted to build a driver that could drive any trucks or any cars, right? That if you think about it, the driving task is pretty similar, whether you're in a car or a truck. And in fact, to be able to drive a truck, you have to have a light vehicle permit first, and then you go and get your commercial driver's license. But when we started, from the experience we had, we knew that there wasn't the technology to see far enough down the road to be able to drive a truck safely. So if you think about if you're driving at 10 to 15 miles per hour like you are in San Francisco traffic most of the time, you can kind of stop in the length of a table. And so, there's a lot of complexity in what's moving around you, and there's a lot of things to interpret, but you don't actually have to see that far to be able to stop safely. In contrast, when you are driving down the freeway with a 18-wheeler, you have to see 2 football fields or more. In fact, in practice, we think you have to see more to do it well to be able to stop. And so there wasn't any LiDAR technology that could do that. And so in 2017 and 2018, we spent a lot of time trying to find a technology breakthrough that would enable that. But until then, we were focused on cars because that was where this technology could be applied. There's lots of valuable and interesting use cases there. As we found this little company in Montana called Blackmore. And for the last 10 or 15 years, the folks who had founded that had been working on this really special kind of LiDAR technology called frequency modulated continuous wave. And without getting too into the weeds, what it means is it lets you see basically twice as far. And you're not, you're much more immune to noise. So like bright headlights can blind conventional LiDAR. They can't blind this kind of LiDAR. And really interestingly, you can see exactly how fast the thing is moving, the same way that when an ambulance drives by, you hear the Doppler effect, the tone shift in the siren.
Of course.
Well, you can use that to measure speed. That's how police radar guns work. Well, we do that with light. So this little dot of light goes out, and we can see how fast the thing that it hits is moving. And so we can see further, and we see how fast they're moving, and we can use that to really understand the world at range. And so when we brought that technology in-house with acquiring Blackmore, we're like, okay, now we have the key parts that would let us to go work in trucking. Should we go do that? And as we thought about the opportunity for this technology, it became clearer and clearer that was the right first market to enter. And so maybe take a moment and talk a little bit about why trucking, right? So in the U.S., if you look around the room you're in, the room I'm in, everything here moved on a truck, right? Like our economy is just 100% dependent on trucking. It's a backbone to our society. And the people who drive truckers, they do an incredibly important job, but it's a really tough job, right? That they will spend days or weeks away from home. They have a lot of more health conditions. They are 10 times as likely to die on the job as the average American. And so this means that despite it being a really laudable and important profession, there's not enough people who want to do it. And in the U.S., we're short somewhere between 60 and 70,000 drivers today. The American Trucking Association expects over the next decade, we're going to need 1 million new drivers. And we don't know where they're going to come from. And so there's a real need. We also accept an incredible amount of kind of collateral damage on our freeway system today on the roads in America, right? 40,000 Americans die every year in traffic fatality or traffic accidents. Of those, about 6,000 are accidents that are related to heavy trucks. And so by having a stable supply of drivers that can do this work, that don't get distracted, don't get tired, but also have superpowers, right? That they can see, the Aurora driver can see in front of the truck and behind the truck at the same time. And it can be paying equal attention to the hazard or vehicle in front of it as it is the hazard or vehicle beside it in a way that I physically can't because my neck and my eyes can only look in one place at a time. And so that there's a real benefit of safety. So that we again see a place where there's not enough people available to do the work, and there's an opportunity to make the work safer and kind of help society. And then we also see it as economically incredibly interesting. So the U.S., the trucking industry is about $1 trillion market today, right? It's trillion with a T, off of 200 billion miles traveled. So it's this incredibly established market that has a real need. And where the unit economics are really interesting. We value driving a truck 3 times as highly as we value driving a car. And so when you think about introducing a new product, you want to be entering a space where there's a desperate need. You want to enter a space where the market ultimately is large enough that you can actually have a real impact in the world. And you don't have to dramatically change customer behavior. And then you want to do it in a place where you have sustainable unit economics, particularly as you bring a product to market where the COGS, the cost of delivering it, are higher initially, and then they can come down over time. And so as we kind of piece this together, like that's the place we should start. And by building a driver that can operate a truck at speed, that driver will be, that intelligence that we build is going to be useful a bunch of other places. It'll be useful to drive light vehicles. It'll be useful to understand the world. And so there'll be a lot of really interesting long-term places to go. But even if all we do is, become the leading provider of automated driving for trucking, that's going to be incredibly impactful and incredibly valuable.
It almost sounds like, and I could be wrong about this, but like it almost sounds like the opportunity in trucking may be more valuable than the opportunity in consumer passenger. Is that right? I mean, because like you said, we're actually short drivers, and if these people didn't have to do this, maybe they wouldn't want to do it, right? Whereas I think we all need to get to where we're going in our regular everyday lives as passengers, but the same doesn't have to be true for the drivers of trucks. Is that right?
That's right. And so exactly, we see this as the most obvious place for this technology to come to market. I do think there's a real opportunity in personal mobility, right? That you get a lot of the safety benefits, or all of the safety benefits are there to be realized as well. The convenience benefits, you could imagine a world where a shared fleet is providing transportation more efficiently for people than owning vehicles. And you see this as, kind of the analog version of this has happened in New York and big cities over time. Like it's inconvenient to have to go find a place to park your car, so you take a taxi or an Uber or you ride the subway. And kind of the cost value proposition is kind of changes. As you bring the cost of delivering that mobility to customers, then it'll become more and more, or cost down of delivering that. You'll get more and more people wanting it. And so you can imagine seeing the shift there over time where you move more people from driving their own cars to riding in this shared service kind of model.
Right. But in terms of like, so that makes a ton of sense. But in terms of like adoption, it feels like the adoption and the uptake would probably be quicker in trucking because there's a real economic benefit to the companies that rely on these drivers and these trucks to fuel their business.
Absolutely. I that's clear, right? That trucking is really a TCO business. Whereas the ride-hailing market, there's a lot more emotion involved.
Exactly.
Right? That, if you think about, if I'm a carrier, a trucking company, I care that the thing got where it's supposed to go safely, that it got there on time, and that I could make money doing it. Whereas if I'm taking an Uber or a car across town, I want to know that it's taking the right route that I like. When it cuts between cars, was it too aggressive and so I'm scared, or was it not aggressive enough and I'm frustrated that we're late, right? So there's a lot more.
And I have options.
And you have options, right? And you may just like driving your car. And so, I talked earlier about not having to change the customer's kind of way of working, right? And so ultimately you have to, if you want to really build a huge business and have a huge impact in the ride-hailing side, you need to change customer behavior from hopping in their car in the garage to getting into a hailed vehicle somewhere. So I think that's going to be interesting. And when it comes to these trucking companies, you talked about the opportunity for them, the financial incentives around this. And this is where it's really exciting from a business perspective, is that today, if you drive a truck, you can only do it for 11 hours a day. And so if you're someone who owns a truck and pays a driver, then you've got that really $150,000 plus asset that's sat fallow for half the day. Whereas we should be able to double that, and that's the opportunity to increase your revenue and make more money and serve your customers better.
Yeah, that makes total sense. Yeah, there's just like all these probably efficiency unlocks that come with transitioning to a fully autonomous driver. You've been in this industry really since the beginning. I mean, even I remember like the early days of Google self-driving programs, seeing the vehicles on the street. And now you're still doing it at your own company and at the forefront of the technology. How have things changed maybe from the technology side from when you started to where they are today? And maybe if you can touch on the fact that there seem to be, if I understand correctly, different types of approaches that are being utilized by the different companies, such as yours, such as Waymo, such as Tesla. There isn't just a sort of single method that you can choose from a technology standpoint. Is that right?
I've had the opportunity to kind of ride and experience the Gartner hype curve firsthand, right? And so back in 2003 and 2009 when I started Google, it was like no one thought this could happen, right? It was kind of this moonshot, crazy idea. And then sometime around 2015, 2016, it was like everyone's going to have a self-driving car tomorrow. Problem solved. And so there was a lot of investment activities, a lot of folks that piled into the space, and that's great, right? That leads to innovation, and that kind of fuels an innovation economy. And then over the last 5 years, we've gone through the dip and the trough of disillusionment. Is this isn't that easy, and I don't know if it can ever be solved. Now we're starting to come out, and I think we're starting to hit that plane of enlightenment or whatever they call it, where the product is really actually useful and starting to kind of live up to the expectations that folks have had. So that's been kind of an interesting journey, and one I certainly wouldn't trade. On the technology front, if you go back to the 2003 vehicle from that DARPA challenge, Sandstorm, it's like Lucy, right, or Cro-Magnon Man, kind of the bridge between the old ideas and new ideas. We had massive computers on board. We had cameras, lasers, radars, and for the first time we had high-definition digital maps. And we started to do some of the early machine learning AI techniques that are kind of the grandparents of what we use in AI today. And so that was kind of the moment where it first all came together. And if you stand back at 50,000 feet, it basically looks the same, right? We use cameras, lasers, radar, computers, maps to make the robust systems work. But along each of those axes, there's been transformational progress, right? Whether it's cameras. If you think back to 2003, you might be able to get a 1 megapixel camera. But with what's happened with the smartphone industry and the explosion of digital photography through that, camera technology is just night and day different. Automotive radar, with the broader adoption of emergency collision mitigation braking, right, where your car will beep at you and help you stop, that's driven a volume in radar that's driven the cost down of that and driven performance up. And so, again, that's night and day from what it was 20 years ago. At the time we first did that 2003 robot, the best LiDAR in the world was it's called a SICK LiDAR. It's a German company. I don't know what SICK means other than not what you normally mean. And it looked like a coffee maker. And it had this like Darth Vader lens on it. And it was just a single plane of data that it would generate from it. And if you look today, and another technology that's been through that hype curve has been 3D LiDAR, where you get volumetric data back from it instead of a plane of data. And we've taken that a step further with our first light technology, which sees further and then also sees the velocity of things. So that's taken a step function. And computation is, like it's everyone laments the death of Moore's law, but it's again night and day what we have on the vehicles today versus what we could put on the vehicles back then. So along every one of these axes, we've seen major enablements that have allowed us to get to where we are today. And then on the algorithmic side, the explosion in ideas of how to use computation efficiently to do reasoning and to do inference has been just, again, amazing to watch, where decision trees and k-means clustering and some of this stuff was what we were doing back then. And, then we saw the advent initially of deep learning, where instead of having to describe the features to the computer, it kind of figured them out as well as learning the relationship between them, to now this very deep learning stuff that is, and the transformer model and what's happening with generative AI today. It's, again, all of these technologies kind of feed into what's enabling us to actually get traction with the automated vehicles on the road today.
Staying on that last point a little bit about the algorithmic improvements and decision trees to now, doing something that's more based on, artificial intelligence, machine learning. If just playing it back to you a little bit, it sounds like what you're saying is previously, you almost had to like manually map out every condition that the vehicle might encounter, whereas now the vehicles are effectively just learning on their own in real time. Is that how we should think about it?
Yeah. So there's a couple of bits of nuance here. So at Aurora, we kind of saw this wave coming, and you can look back to 2017. We put a blog post out about how important this idea of data was, and using machine learning technology is what we called it then. It's now called AI to make this happen. And part of what we've seen over that time is the importance of, like, one, you cannot solve this problem with a if then else kind of reasoning.
There's too many cases.
There's too many cases, too complicated, too subtle, right? And so the way we've approached it is an approach we call verifiable AI. So there are some things in the world that you just know to be true. You know that you should stop at a stop sign. You know that when you're driving down the road, you should stay on the road, right? And so we can encode these guardrails and then use AI to actually blend between them to get humanistic, safe, quality driving. And so, like, concretely, an example, if you, I don't know if you have kids or how old they are.
I do have kids, yeah.
But if they learn to drive, at some point you're going to tell them, keep 3 chevrons or 3 seconds behind the vehicle in front of you, right? That's kind of what the driver handbook says. So that sounds like a really straightforward rule, except what happens when another vehicle cuts in front of you, right? It's out of your control at this point. So they're in front of you. Do you hammer the brakes really hard to maximize the gap, or do you kind of just let it coast? that's kind of a function of, well, what's that car in front of you doing? What can you see beyond that? Are you planning to make a lane change? Are you planning to, exit the freeway? There's a lot of factors. What's the vehicle beside you doing, right, that contribute to how you respond to that behavior. So that's the perfect place to use AI to actually understand the scene and then generate behavior like expert human drivers will, while not giving up the constraints that we want, and be able to go and kind of verify that in these cases that are clear cut, that we're going to get the right answer out of the system.
And like you said, because of, cameras, the different sensors you may have in the vehicle, the autonomous vehicle could detect far more situations than a human being could at any given moment in time, right? It could be looking at the chevrons and the car next to it and the distance of the vehicle behind it all at the same time, and making a decision based on all of the information, right? Which a human could just never do.
Yeah, it's one of those underappreciated superpowers that, and back when I was at Google, we had an incident where one of our vehicles was driving in downtown Mountain View, and a cyclist came whipping around the corner on the wrong side of the road at night. And the car did exactly what it should have. It stopped, and the cyclists went on their way. And so, this became a little clip I would show, like, look at how good it is. It reacted immediately. This person come around the corner, and you would have a hard time seeing it at night. And I probably showed that video, a dozen times before I realized that there was actually a person stood on each of the three of the four corners at the intersection, that there was two vehicles lined up at the intersection, right? And because my natural instinct and my attention got focused on the thing that mattered, right? That cyclist coming around the corner, the most important thing in the moment. But the car was able to appreciate that, okay, that matters, but there's also a person here I need to care for, and that person, and this person, and the other vehicles I need to pay attention to. And because it was because of the nature of the processing in the system, it didn't become overly foveated, and that allowed it to react appropriately. We just saw a situation like this happen on the freeway for us. So one of our vehicles, one of our big trucks, is run down the freeway at 65 miles an hour. As we're approaching, you can see that there's a truck stopped in the gore point where the freeway splits. And so that's interesting. And then as you get a little bit closer, there's a person out, servicing the truck or, checking something out in the middle of this gore point. And so as a driver, that's a really dangerous situation. So you're going to pay a lot of attention to that. But right as that's happening, as we're getting close to it, somebody else, a little pickup truck, I think with a trailer, realized they've missed their exit and just sweeps across in front of us to try to get across the exit. And so as a human paying attention to this, I'm paying attention there, and I'm certain I would not have seen that other vehicle. In contrast, the Aurora driver is able to, okay, I'm going to move over a little bit to make space for that, but I'm going to begin braking because I see this person cutting through, and just instantaneously deal with all of this interesting stuff.
What happens in a situation where the machine decides like there are actually no good options, or is it ever in a, I thought of that when you mentioned that there are people on all four corners. Like, do they ever find themselves in that situation? How do they handle it? Yeah.
So the first is these situations don't really come up, particularly if you practice defensive driving, right? Yep. Where you're creating space and you're creating optionality as you're driving. And the Aurora driver does a good job trying to achieve that. But bad things can happen out of your control, right? Somebody can kind of take space that they shouldn't have, and it can get complicated. And at that point, we've encoded in the Aurora driver the concept of a duty of care. This idea that that's kind of the way we think about how people should drive down the road, is that you owe a duty of care to the other folks on the road, and that your action shouldn't unduly put other people at risk. And so that kind of, if you start to follow that line of reasoning, you end up with really natural outcomes on how you should respond to these kind of challenge cases.
It also strikes me that there's, if I understand correctly, different schools of thought and how these things should be tested and deployed. For example, my understanding is Waymo is taking a bit more of a conservative approach, staying on very specific, almost like tracks that it is trained and designed for, whereas something like Tesla is beta testing out in the open, really leaning on drivers of the vehicles to help guide these things to avoid any disastrous situations. Where does Aurora sort of land on that spectrum, and how do you think about rolling this technology out?
Yeah, so our approach has been to kind of pick areas to operate in and have confidence that the system's going to operate safely within those, and then expand out from that. And one of the benefits we have is that the freeway system is really self-similar. So if you learn to drive on a bit of freeway in Texas, it's going to look like a bit of freeway in Arizona or Minnesota. And fortunately, a lot of long-distance trucking, of course, uses the freeway network. And so for us, it will be a thoughtful, controlled rollout. We're delivering, a really important bit of technology, and we want to make sure it gets out into the public space safely. I think there's some real challenges where you're kind of throw it out there and hope, right, that it all works out. And so, we're taking a much more deliberative approach to that, and it's kind of part of our safety culture and DNA we have here.
Right. So it sounds a little bit more similar to Waymo's methodology.
The thing I would kind of push on a little bit is it's not so much on tracks, but it's constrained to areas, right? Because it's not like we're creating a virtual railroad. It's that we're really using the road and we can move dynamically through it and move off to the side and stuff. But it's like, this is the places that we're confident this will work safely. Let's use it there. And then let's grow that. And we can grow that relatively quickly, but let's be thoughtful about it.
Yeah, that makes sense. One thing I've been thinking about with trucking is that I assume is a challenge is maintenance. I think about in passenger vehicles, even if I'm not driving the car, I'm there with it. I could either perform maintenance on it myself. I can coordinate the maintenance. But when you're doing trucking and you're driving these huge trucks literally across the country, with no human driver in it, how do you handle something like maintenance? That sounds like a really complicated problem.
Yeah, so there's two parts to it. So one is the proactive part, in that these are fleet vehicles, and so the folks who own fleets understand, okay, here's the proactive work that we need to do to, make sure the belts are tightened and do inspections on the vehicle to make sure that there's not something about to fail. And so there's a lot of work you can do to kind of minimize the risk that there's failures along the way. But of course, things break. And so part of what we have built into the Aurora Driver is what we call the fault management system, which is really a thing that's just constantly looking thousands of times a second. Is everything okay? Right? Is the computer not overheating? Is the software turning over at the speeds that it's supposed to? Is the tires all at the right pressure? Is the brake system fully available? And so thousands of these checks happen every second. And so along the way, we identify, okay, something's not right. And then we figure out, what does that mean? If say, for example, we could detect that the tail light is out. I don't think we actually detect tail lights out, but we detected the tail lights out, let's say, for a moment. That's something where we'd say, okay, next time we get to a depot, let's make sure there's a service action. Someone knows I need to replace the bulb in the tail light. Versus maybe there's something, one of the sensors fails for some reason, breaks, gets hit by a rock, something like that. Okay, I can't see quite as well as I would normally, but I can see pretty darn well. So let me get to a safe place to pull off the freeway and stop, and then figure out what to do from there. Yeah, same way if a driver suddenly is hurt, right? They're going to get off the road and kind of find a moment to collect themselves and then figure out what to do from there. And then you could imagine a tire blows out on the road. Well, we're kind of got to get off the road at that point. And so it'll detect that, pull the shoulder and stop, and obviously wait for somebody to come and fix the tire before it gets on its way again.
It sounds like for vehicles, right, as the stakes get higher, the more testing, the more proactive you need to be in monitoring these things. Actually, the first thing that came to mind to me when you were explaining it was airplanes, right? When the slightest thing is wrong with an airplane, it gets fixed, right? There's no chances taken. And it sounds similar here. You're just constantly testing and monitoring.
And this is part of the way that the industry works today, right? That anytime before a truck goes on the road, there's an inspection that the operator has to perform. And this is why you need an extra level of license to drive a big truck. And so we kind of are using that, and it's, again, consistent with the way that our customers operate their business today. And then we're layering on top of that another level of visibility and safety that'll help manage this.
Yeah. I also, probably a similar question, how does fueling work? In that, again, there isn't somebody on board to help fuel this thing. So I'm guessing you have to fuel it in a dedicated area where somebody kind of knows what they're dealing with.
Yeah. So what I'd start with is, first, they have really big fuel tanks.
Yeah.
Right. So, they can drive like 1,200 miles or something like that. And then you're right. So what would happen is, initially, we do the simple thing, which is somebody fills it up before it goes out, and then they send it on its way. Eventually, what I expect will happen is that we'll have partnerships. Our customers will have partnerships with Flying J or whoever else along the truck stops. And the truck will pull in, and an attendant will, have a credit card on file effectively, and, fill it up, and then it'll get on its way again. So I think there's a pretty straightforward, low-tech way to do this without having to have robot snakes doing something crazy.
What volume of these vehicles are on the road today performing these tasks?
Yeah, so we have about 30 trucks that are on the road today. They operate between Dallas and Houston and Fort Worth, El Paso. And we're pulling real loads for customers. We work with companies like FedEx, Werner, Schneider, Uber Freight, and we're pulling real goods for these companies to help their customers get stuff where they need to go. It's exciting to see. These customers kind of have the vision for what this is going to mean for their business, and they're working with us to make sure we're building the right thing to serve them.
And you mentioned earlier that, like, you're sticking to certain areas to sort of perfect the technology before you expand the area. I also have to imagine that you're picking a location maybe based on legislation and working with local governments. Like, speak to that. I mean, I think this is going to be really fascinating to see how the deployment of both automated trucking and passenger vehicles plays out. And obviously, we're seeing stuff in the news about this all the time as it relates to, let's say, crashes of FSD and incidents with Waymos getting lit on fire. Like, how do you think about that side of this challenge? Because I'm sure that's not going to be an easy thing to figure out.
Yeah, so we've really tried to look at where the right places to operate. And we look at that from, where is it commercially important? Where is it technically viable? And where is it viable from a regulatory perspective? And so it turns out that Texas is one of the, the massive amounts of trucking in Texas. The Dallas-Houston lane that we're on, I think there's 6,000 truckloads a day, right? So it's pretty important in terms of moving goods from A to B. And so that checks that box. Across the U.S., there's this southern freight corridor that stretches, through Texas to L.A. and east through Atlanta. And the reason why there's a southern freight corridor is because it sucks to drive trucks in bad weather. And there the weather's more clement, and so there's a lot of goods move that way. And so that helps us as well, because as you think about bringing a product to market, we need to bring it to market in a way that's safe, but we want it to be the minimum viable product, not have to kind of boil the ocean the first time out the door. And so that, it's good for us to operate in a place where it's valuable to customers, and we don't have to worry about, massive amounts of bad weather. And then, as you point out, the regulatory environment matters a lot. And so the great news is that across the vast majority of the United States, if we were confident in the self-driving truck's safety, we could put it on the road today. It's something like 40 of the 50 states. And Texas has been very excited about this technology, very supportive throughout the whole development process of it. And we've invested a fair bit of energy in building relationships both at the state, local, and federal level to help the regulators and policymakers really understand the technology, understand the opportunities with it, understand the risks, understand how we're approaching it. Because the last thing you really want is a regulator who's surprised, right? That's how you get weird knee-jerk behavior.
Yeah, of course. Interesting. So it almost sounds like you almost have to like self-regulate in a sense.
Yeah. So the way I think this is one of the things the U.S. has got really right in automotive is that there's a set of rules that you have to comply with called the Federal Motor Vehicle Safety Standard. And so long as you do all of those things, your product complies with them, then you can bring a product to market. And then it turns out that the regulators have a stick, If they think that you're doing something unreasonable, then they can take the product off the road. But we go through and we make sure that we comply with all those rules in the Federal Motor Vehicle Safety Standard. There's not a whole lot there that talks about automated driving. So the product, has the space to be innovative as long as it complies with those things. And then we work with the states who regulate the licensing of drivers on their roads. That's why you have a California license or a New York license rather than a U.S. license, to make sure that the regulations enable this technology in their states. And again, the vast majority of states have either implicitly or explicitly allowed this technology.
It almost sounds like there's kind of this lack of regulation for autonomous vehicles on the road right now. Do you feel that is do you feel that is intentional to foster innovation in this area, or is it sort of just slowness or sort of lack of progress on the regulatory side to keep up with how fast this space is moving?
I think it's been an intentional and the right approach. So at the Department of Transportation, they've issued, I think, 3 different guidelines on how to do this well, but they've resisted putting in place federal regulations. And that feels right to me, because the technology, while we're in the heart of dealing with it and seeing it, it's still not even a drop in the bucket in terms of, our roadways across the U.S. and the amount of vehicle miles traveled. And so I think it's appropriate for regulators to kind of understand and then put regulation in place. I imagine if the Wright brothers were trying to make aircraft and they had to deal with current FAA regulations, which are there for perfectly reasonable reasons, we would not have aircraft today. And so finding the right time to kind of marry up our understanding with the challenges and risks with the necessary regulatory regime is appropriate. And I think the federal government has taken prudent steps in that direction.
Yeah, maybe just since we're on this topic, to go in a slightly different direction, and then we can come back to autonomous vehicles. There's obviously a very similar debate happening right now with AI more broadly, right? These models and the technologies and the architectural approaches are evolving and accelerating so quickly that there's obviously been a lot of talk of regulation. And there seems to be two schools of thought on that as well. And like everything in America, it's very polarized right now. How do you think about, through this same lens as you just described, regulation on automotive and even aircraft, how do you think about it with AI more broadly?
Yeah, I'll admit to having not thought deeply about this. But generally, I think when you write regulations, you should regulate the outcome rather than the how you get there, right? In our world, I think it would be very silly to write a regulation that says you need to use 905 nanometer LiDAR, right? Just because a lot of folks are using that. What you really want to regulate is that, the vehicle is able to stop in this condition or is able to react to that kind of situation. And so I think in the AI world, I think we should think about what is the outcome we want as a society, and then, frame the regulation that way. Because, I don't think it makes sense to talk about number of nodes in the network, right? Because that's going to evolve. And, people will play cute games to, well, you said, 12 billion and I've got 11,999,999,999 nodes. And so I'm not, whatever is the right bar. But if we think about what we want and then think about regulation from that point of view, I think that can be very healthy.
Right. So regulating the outputs, not the inputs, if that makes sense. Yeah, that's really smart. What about the other thing that strikes me as being critically important in your industry is transparency. I feel like a lot of the pushback, in the media, with government, is sometimes in some of these incidents, lack of transparency. Well, there was an accident, but we don't know whose fault it was, and we actually don't even have the data or the video footage to be able to understand it. How does Aurora think about transparency as a way to further the technology in collaboration with all parties at the table?
We see it as one part of the way that you build trust, right? And we're doing something new and complicated, and that'll have wide-reaching implications. And so it's appropriate that the regulatory bodies, the policymaking bodies, take interest. And it's our job to help them understand it, be educated on it, and be able to make decisions that society has kind of put them in the position to make. And so we think transparency is valuable. I think it's important when you provide transparency that you're able to provide context, right? So that people can understand what these numbers mean. Because one of the challenges we face is that we can provide much more detailed information than we get from the fleet of human-driven vehicles out in the world. And so how do you make sure that the apples are compared to apples, not compared to the imaginary orange or something else, right? And so being transparent with regulators, helping them come along the journey, helping them not be surprised is really, really important.
Okay, well, no self-driving conversation is complete without predictions. So we got to get into some predictions now, if you don't mind. Where are we at in the adoption curve of this technology? I guess both across trucking and passenger vehicles. When are we going to get to a future where, more of us are actually riding around in self-driving vehicles, or trucks on the road are more self-driving than not?
Yeah, so I think it's incredibly exciting to see what's happening in San Francisco right now. It's just up there yesterday, and there's Waymos with nobody behind the steering wheel everywhere, right? And that you can call one and get a ride in it. And it's kind of the vision that, we had 10 years ago about what this could and should look like. And it's just incredibly exciting to see. So I think if you live in the areas where this will start to roll out, you'll be able to pay or hail these things and get a ride. And I think that's going to be awesome. And I've had a ride in them, and it's kind of mind-blowing, and I do this for a living. And then with trucking, our trucks are on the road today. They mostly drive themselves today, almost all the time. We're working towards the end of this year be the point where we start to operate trucks with nobody in them. And we'll follow very much a crawl, walk, run model. So we'll start with one and then build up, and hopefully, our intent is by the end of next year to have tens of them on the road, and then hundreds the year after, and then kind of grow from there. So it's a really exciting time. And for those of us who've been kind of thinking about this and working towards it, to see these improvements in quality of life for folks, improvements in safety on our roads, improvement in economic efficiency, it's starting to happen. So really neat.
Do you think my kids who are young, will they need to get driver's licenses when they grow up?
I think it'll depend where you live, right? I would say in major urban areas, you wouldn't need to. You may want to, but you wouldn't need to. My kids are now 21 and 19. And so they were actually a little resistant to getting their driver's licenses.
In Texas?
No, in California.
Oh, okay. Got it.
So, it took a little bit of nudging to like, hey, this is actually a useful life skill for the next at least few years. We'll see. But I'm continue to be bullish, and I do believe that if you live in a major metro area, that you'll have the opportunity not to.
Fascinating. And it sounds like your mission is to move beyond trucking at some point. When can we expect that from Aurora?
Yeah, so our mission is to deliver the benefits of self-driving technology safely, quickly, broadly. The first part of that is going to be in trucking. And then we'll see, right? We really think that it's important to have focus, get a product out the door, get adoption with that, get to the point where we're a self-sustaining business. And then kind of the opportunities are limitless from there.
Yep. Chris, this has been fascinating. I learned a ton, and I'm sure listeners did as well. So really, really thank you so much for the time today.
No, I really appreciate it. Thanks for your time, Michael.
Thanks for listening to Generative Now. If you liked what you heard, please do us a favor and rate and review the podcast on Spotify and Apple Podcasts, and make sure you subscribe. And if you want to learn more, follow Lightspeed at Lightspeed VP on YouTube, X, or LinkedIn. Generative Now is produced by Lightspeed in partnership with Pod People. I am Michael Mignano, and we will be back next week. See you then.